Minute Maths. Today we are going to be talking about mathematical induction. So what exactly is mathematical induction? So mathematical induction is a technique used to prove mathematical equations for any natural number. A natural number is just a non-zero, non-negative whole number. For example, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. Just any whole number that's positive and non-zero. So mathematical induction can be used to prove that a statement P, any statement, in this scenario, we won't say statement P, holds for an infinite amount of natural numbers. So statement P is just simply the equation for any partial sum. So for example, if I give an example of a series over here, we can have 1, 2, 3, ... all the way up to, let's just say, k. So our statement P in this scenario will be k times k plus 1 over 2 equals to the partial sum of k. So using mathematical induction, we want to prove that this right here, statement P, is true. For the two easy steps of mathematical induction. So first, we have our basis step. So in this step, we're just simply proving that one natural number, usually 1, plugged into our equation works. So if we use the same equation as before, we have 1, 2, 3, all the way up to k. And our statement P will be k times k plus 1 over 2. Then this is our statement P. And we want to plug one natural number into the statement P. So let's just choose 1 because it's the most common one we use. So simply what we're doing by plugging 1 into our statement P, we're just simply proving that for one number, statement P works. So now for the second step. So in this step, you want to prove that not just one number works for statement P, but for any number works for statement P. So what we want to do here, we want to assume that this whole entire sequence right here, this whole entire sequence, all the way up to k, you want to assume that it actually equals to statement P right here. After you assume that, you want to plug in k plus 1 to our statement P in order to achieve the proof. Okay, so let us use an example to show the process of mathematical induction. Okay, so we're using the same sequence as before. Okay, so let's go to my board over here and pull my pen real quick. Okay, so still 1 plus 2 plus 3 all the way to k, right? So now we'll first do the first step, which is the basis. Okay, so let's just choose 1. This is the easiest for us, right? So let's just circle 1 here because we're using 1. And let's remember our statement P, right? Which is k times k plus 1 divided by 2. So all we need to simply do is plug 1 into this equation. So let's do that right quick. So we have 1 times 1 plus 1 over 2. Now we know that 1 plus 1 equals to 2, and 2 times 1 still equals to 2, and 2 divided by 2 equals to 1. And since we're using 1, the only number in the partial sum is 1 itself, right? So now we know 1 equals 1. So for this natural number right here, we know that the statement P works. Okay, so now let's go on to the second step, which is induction. Okay, let me clear everything right here. Okay, so now we're going to assume that 1 plus 2 plus 3 all the way to k. This equals to k times k plus 1 over 2. Now we're only assuming this, but this is just a step in the induction process, right? So now since we are assuming this is true,
Now we can use k plus 1 and put k plus 1 into this sequence, right? So now let's rewrite the sequence with k plus 1. So you have 1 plus 2 plus 3 all the way to k. But then we also have k plus 1. Okay, so once we have this equation, we can rewrite this as saying k times k plus 1 over 2 plus k plus 1. Since we can rewrite this way because we're assuming that 1 plus 2 plus 3 all the way to k equals to k times k plus 1 divided by 2. So once we have defined 1 all the way plus all the way to k, we can simply write it as k times k plus 1 divided by 2 plus k plus 1.
Okay, so now another partial sum of k plus 1, or 1 plus 2 plus 3 plus 4, all the way up to k plus 1, is equivalent to k times k plus 1 over 2 plus k plus 1. But now we need to simplify this. So we need to add, right? But in order to add, we need the same denominator. So we need to add a denominator of 2 to k plus 1. So we can add that. But we also have to multiply the top by 2 in order to keep the values constant. So now we can simplify. We have k times k plus 1 plus 2 times k plus 1 over 2. We're going to simplify this more. If you look closely, this is just simply a distributed version of 2 plus k times k plus 1. So we can erase everything, and we can write is equivalent to k plus 2 times k plus 1. Because the other answer we had was just a distributed version of this, because we had k times k plus 1 plus 2 times k plus 1. You see, so just distributed. It was just combine everything right here. So now let's erase everything and go to other side of the equation. So we have our statement P, which is just simply x times x plus 1 over 2. So now we also want to plug k plus 1 to this. So we will get, change the color here. We have k plus 1 times k plus 1 plus 1 over 2. If we simplify this, this will equal to k plus 1 times k plus 2 over 2. Now, if you look closely, this is the same thing as the previous answer we got. You see, this is equivalent to the other answer. Therefore, we know statement P right here has to be true.